Hello everyone, myself Chandan, working in Tumkur University. In this video, I have solved this problem and few more problems. That is, that the sequence xn defined by x1 is equal to root 3 and xn is equal to root of 3 into xn is convergent and converges to 3. And in the last video, I have explained and the similar problem, that is, show that the sequence xn where x1 is equal to 1, xn is equal to root of 2 plus xn minus 1 is convergent and converges to 2. To prove this theorem or to prove this problem, I have used mathematical induction. By using mathematical induction, I have explained the last problem. The similar way, using the same mathematical induction, I am proving this result. That is, prove the sequence xn defined by first term is root 3 and generally nth term is defined by root of 3 into xn converges to 3. Given xn x1 is root 3. First, I am proving, I am checking about monotonicity, monotonically increasing. Okay, fine. First, I'm checking about is that the sequence is monotonically increasing or decreasing. Because if the sequence is monotonically increasing and it is bounded above, then the sequence is always convergent. I'm coming to this part later. Just I'm proving about convergence. So given x1 is root 3. So general representation of nth term is xn plus 1 is equal to root of 3 into xn. In this, put n is equal to 1, we will obtain second term. Put n is equal to 2, we will obtain third term. So put n is equal to 1, we will have x2 is equal to root of 3 into root 3. Clearly, this value is greater than root 3 because root 3 value is 1.7. Approximately, its value is 1.7, and root of 3 into root 3 is around it is 3.7. Value is always greater than 1.7. That is, root of 3 into root 3 is nothing but x2. Root 3 is nothing but x1. So we have proved the first inequality, x2 is greater than x1. In mathematical induction process, first we have to prove for n is equal to 1 and later we assume the result is true for nth term and later we have to prove for m plus 1th terms, that is n plus 1th term. So give here the inequality is true for first term. First term the inequality is x2 is greater than x1. So now suppose the result is true. Suppose the result is true for xn. For nth term, the result is true. That is xn, x2 is greater than x1. xn is greater than xn minus 1. Here we have assumed that the result is true. That is xn is greater than xn minus 1. Now we have to prove for n plus 1th term. Here we assume this result is true. So therefore consider this result. xn is greater than xn minus 1. xn is greater than xn minus 1. Multiply 3 on both sides. If you multiply 3 on both sides or if you multiply any positive number, the inequality remains same. 3 into xn minus 1. Take root on both sides. Root of 3 into xn is greater than root of 3 into xn minus 1. Given xn plus 1 is equal to root of 3 into xn. Root of 3 into xn is nothing but xn plus 1. And here if it is n, then add 1 to both. Add 1, we will get n plus 1th term. That is xn plus 1. And the similar way, here it is n minus 1. Therefore, we will get xn. Xn is nothing but root of 3 into xn minus 1. It's a general term. Xn plus 1 is root of 3 into xn. Root of 3 into xn. If you put n plus 1 is equal to n, we will obtain root of 3 into xn minus 1. Therefore, xn plus 1 is greater than xn. By mathematical induction, by mathematical induction, the result is true. The result is true for all n belongs to natural number. That is, xn plus 1 is greater than xn for all n belongs to n. This is the condition of monotonically increasing sequence. Implies the given sequence is monotonically increasing. The given sequence is monotonically increasing. If you prove that the given sequence is bounded above, is enough to show that the given sequence is convergent. So now check for monotonically increasing, bounded above. Given xn plus 1 is equal to root of 3 into xn. And with first term is root 3. x1 is equal to root 3 is always less than 3. Root 3 value is 1.7. x1 is less than 3. Suppose the same inequality, that is xn less than 3, holds. Then we have to prove for n plus 1 term. Suppose the result is true. Suppose the result is true for xn. That is, the result is the inequality, the same inequality. That is, xn is less than 3. Xn is less than 3. So we have, we have assumed that the result is true for xn. So consider this result, xn less than 3, which implies multiply 3 on both sides. 3 into xn is less than 9. Taking root on both sides, we will have root of 3 into xn. Root 9 is nothing but 3. Root of 3 into xn is nothing but xn plus 1 is also less than 3. We have proof for n plus 1th term. For by mathematical induction, the result is true. By mathematical induction, the result is true for all n belongs to n. That is, xn less than 3 for all n belongs to n is the condition of bounded above, which implies the given sequence xn is bounded above. We have a theorem on the convergence of the sequences. If any sequence which is monotonically increasing and bounded above is always convergent, and in fact this converges to least upper bound. xn is monotonically increasing and xn is bounded above. xn is monotonically increasing and xn is bounded above, which implies xn is convergent. xn is convergent. So up to now we have arriving at convergence of a sequences. Convergent of a sequence. So if a sequence defined by xn plus 1 is equal to root of 3 into xn with first term is root 3 is always convergent. Is always convergent. We have proved this result, convergence. Now we have to prove that the given question is not only they have proof or they are asked to prove convergence of a sequence, but also they have said that converges to 3 itself. Prove that the sequence xn defined by x1 is equal to root 3 xn plus 1 is equal to root of 3 into xn converges to 3 itself. This converges to least upper one, and in fact the least upper one here is 3. X1 is equal to root 3. So if any sequence is convergent, or here xn is convergent, which implies limit of that nth term as n tends to infinity, always it has some finite value, call it as some L. If limit of xn is equal to L, which implies limit of xn plus 1 as n tends to infinity is also L, which is same as limit of xn minus 1 as n tends to infinity. Okay. So apply limit for this sequence. And sequence is xn plus 1 is equal to root of 3 into xn. Apply limit on both sides. Limit of xn plus 1 as n tends to infinity is equal to root of 3 into limit of xn as n tends to infinity. Since the given sequence is convergent, limit of xn is also L, limit of xn plus 1 is also L. L is equal to root of 3 into L. L is equal to root of 3 into L. Squaring on both sides, we will have L square minus 3L. L squaring on simplified, we will have L square minus 3L is equal to 0. L into L minus 3 is equal to 0, which implies L is equal to 0 or L is equal to 3. So, whether the sequence is converges to 0 or converges to 3. Since given sequence is monotonically increasing, monotonically increasing with first term. With the first term is x1 is equal to root 3 is always greater than 0, which implies xn is also greater than 0 for all n belongs to n, which implies xn is a positive term sequence. Xn is a positive term sequence, and in fact it is increasing and start from root 3, therefore it always converges to some positive value which must be always greater than root 3, which implies limit of xn as n tends to infinity is equal to 3, or xn converges to 3. Xn converges to 3 because it starts from root 3 and it is increasing, therefore it is converges to some value which is greater than root 3. Therefore xn converges to 3. So given problem is xn is equal to xn defined by x1 is equal to root 3 and xn plus 1 is equal to root of 3 into xn. So by using mathematical induction, I have proved this problem. First I have proved for check for n is equal to 1 and the same inequality, as we later assume that the same inequality is true for nth term, and we have then proved for n plus 1th term. For both to prove monotonically increasing as well as bounded above condition, I have used mathematical induction. So we have arrived at the result that xn is convergent and it converges to 3. So the next question is, show that the sequence xn defined by xn is equal to 1 by n plus 1 plus 1 by n plus 2 plus so on up to 1 by n plus n is convergent. Mainly this type of problem helps in solving many jam questions, or if you thorough with how to solve this type of question, we can generalize those type of problems, whether this type of problems are convergent or not. If it is convergent, for what values of these sequences converges. It's mainly important for semester examination also, and to solve any jam examination questions. So given xn is 1 by n plus 1 plus 1 by n plus 2 plus so on up to 1 by n plus 1. For this sequence also, if the sequence is monotonically increasing and bounded above, that's enough to say for convergence of a sequence. So given xn is 1 by n plus 1 so on up to 1 by n plus n. So the monotonically increasing condition is xn plus 1 minus xn is greater than 0. We can apply this condition directly for above problems also. That is xn plus 1 is equal to root of 3 into xn. But mathematical induction is too simpler process, so I have used mathematical induction process. Now I am using this result xn plus 1. If xn is this term, then xn plus 1 is nothing but simply replace n by n plus 1. N plus 1th term is nothing. Replace n by n plus 1. We will have 1 by n plus 2 plus 1 by n plus 3 plus so on plus 1 by n plus 1 plus n plus 1 2n plus 2. This is xn plus 1. So uh, I will return few more terms before this 1 by 2n plus 2. Those terms are 1 by xn plus 1 is nothing but 1 by n plus 2 plus 1 by n plus 3 plus so on plus this term is 1 by 2n plus 2. Previous term is 1 by 2n plus 1, and before the previous term is 1 by 2n. In a similar way, I will return few more terms before this, that 1 by n plus n. Xn is 1 by n plus 1 plus 1 by n plus 2, 1 by n plus 2 plus so on plus 1 by n. I think that term is not needed. Okay, that's enough. So subtract this to xn plus 1 minus xn is nothing but these terms are get cancels. Xn plus 1 minus xn. If it is greater than 0, then it is monotonically increasing. These terms are get cancelled and these terms get cancelled. We left out with 1 by 2n plus 1 plus 1 by 2n plus 2 xn plus 1 minus xn 1 by n plus 1. And 2n plus 2 is always greater than 2n plus 1. 2n plus 2 is always greater than 2n plus 1 because this n is nothing but natural number. 1 by 2n plus 2 is always less than 1 by 2n plus 1. If you take reciprocal, the inequality changes. Therefore, that is 1 by 2n plus 2 is less than 1 by 2n plus 1. That is 1 by 2n plus 1 is greater than 1 by 2n plus 2. Therefore, the equality changes. If you change equality to greater than, 1 by 2n plus 1 is greater than this term 1 by 2n plus 2, and retain this as same 1 by 2n plus 2 minus 1 by n plus 1. Therefore 1 by 2n plus 2, 1 by 2n plus 2, 2 by 2n plus 2 minus 1 by n plus 1, which is nothing but 1 by n plus 1. 2 to get cancelled, we left up with 1 by n plus 1 minus n. 1 by n plus 1 is always greater than 0, which implies xn plus 1 minus xn is greater than this. We have proved this generally, that is xn plus 1 minus xn is greater than 0 for all n belongs to n. For all n belongs to n, xn plus 1, if you take any n, this result is true. That is xn plus 1 minus xn is always greater than 0, which implies xn is, given sequence xn is monotonically increasing. Monotonically increasing. If we prove that the sequence is bounded above, it's enough to show that the given sequence is convergent. So xn is monotonically increasing. Now we have to check for whether the sequence is bounded above or not. Given xn is equal to 1 by n plus 1 plus 1 by n plus 2 plus so on plus 1 by n plus n. Okay. 1 by n plus 1, call it as some equation 1. So n plus xn is n plus 1 is always less than this n plus n. Right? This is natural number. Something like 3 plus 4, 3 plus 1 is always less than 3 plus 3. 5 plus 1 is always less than 5 plus 5. So 1 by n plus 1 is always less than n plus n. 1 by n plus 1 is greater than 1 by n plus n, or 1 by n plus n is less than 1 by n plus 1. 1 by n plus n is less than 1 by n plus 1. This term is greater than this term. This term is greater than this term. Okay. One by n plus n is less than 1 by n plus 1. Similarly, n plus 2 is greater than n plus 1. 1 by n plus 2 is always less than 1 by n plus 1. And a similar way, 1 by n plus 3 is also less than 1 by n plus 1. Right? So this equation 1 implies xn is equal to 1 by n plus 1 plus 1 by n plus 2 plus so on plus 1 by n plus n. But 1 by n plus 1, retain that same 1 by n plus 1. But 1 by n plus 2 is less than 1 by n plus 1. 1 by n plus 2 is less than 1 by n plus 1. 1 by n plus 2 is less than 1 by n plus 1. And similarly, 1 by n plus 3 is also less than 1 by n plus 1. And similarly, 1 by n plus n is also less than 1 by n plus 1. 1 by n plus 1, 1 by n plus 2, so on up to 1 by n plus 1. Here it has n terms, 1, 2, so on up to n, it has n terms, therefore 1 by n plus 1 plus 1 by n plus 1, so on up to n terms, therefore that is nothing but n by n plus 1. So simplify this, we will have 1 by 1 plus 1 by n. So xn is less than 1 by 1 plus 1 by n, which is nothing but, can we write it as xn is less than 1? Because denominator quantity is greater than the numerator. This n belongs to natural number. If n belongs to natural number, 1 by n is always greater than 0. Therefore, 1 by 1 plus, or just add 1 to this term. Just add 1 to this term. 1 plus 1 by n is greater than 1. Add 1 to both sides. Therefore, 1 by 1 plus 1 by n, 1 plus 1 by n is greater than 1. Or 1 by 1 plus 1 by n is always less than 1. Therefore, 1 by 1 plus 1 by n, this is always less than 1. Therefore, xn less than 1, this result holds for all n belongs to n. Xn less than some real number for all n belongs to them. For every term in a sequence is less than some real number is nothing but if this result holds, the sequence is said to be bounded above, which implies xn is bounded above. Xn is bounded above. Xn is monotonically increasing and xn is bounded above, monotonically increasing and bounded above. This result satisfies, which implies xn is always convergent. Here we are checking for convergence. If you check for convergence, if you prove that xn is monotonically increasing and bounded above, it's enough. So the given sequence is xn is equal to 1 by n plus 1, 1 by n plus 2, so on up to 1 by n plus n. To prove that this sequence is convergent. So to prove this theorem, I am using the result of monotonically increasing as well as bounded above. So I am taking n plus 1, xn plus 1, xn plus 1 minus xn is greater than 0, therefore it is monotonically increasing. And for bounded condition, I have just changed equality to less than, therefore with the help of these inequalities. So clearly these inequalities are true because of natural number. Xn is equal to 1, therefore xn less than 1 for all, xn less than 1 for all n belongs to n, therefore xn is bounded above. Here 1 by n is greater than 0, 1 plus 1 by n is always add 1 to both sides. Inequality doesn't alter. Taking reciprocal, then inequality alters. For less than 1, therefore xn less than 1 for all, which is nothing but the sequence is bounded above. Therefore, the given sequence is convergent. Okay, thank you.